Hi everyone, welcome to techpix.com. The project that we will be demonstrating today is an IoT-based LPG leakage detection system in which we will be using Internet of Things to detect the presence of leaked LPG gas in the kitchen, as the name suggests. So in this project, we will control the supply of gas through the Internet of Things, and being a home security and fire safety system, this project will automatically send a message on our mobile through the Android app as soon as it detects the leakage of gas and immediately cuts the supply of gas off. So now let's go through the constituent assembly of our LPG leakage detection system. First of all, we have here an LPG cylinder for the supply of gas. Then we have a burner to which the gas would not be supplied directly, and instead there would be a solenoid valve in between whose open and closing operation would be controlled using Internet of Things. So by default this valve would be in open position, and first of all it would check the availability of internet. If the internet is on, then it would go for checking the status of safety. Now here you can see, if the status is safe, that is, the gas leakage is 0%, then the solenoid valve would supply the gas towards the burner, which will be demonstrated in the video later. So next, in order to portray the leakage of gas, we have made here an external extension which is controlled by a valve. So with this knob, we will control the supply of gas. Above the knob, we have here the MQ6 LPG sensor, which works on the principle of absorbing the gas particles and immediately converting that signal into some other form such as electrical or magnetic. So as soon as we turn the knob, the gas supply moves towards the sensor, and the sensor immediately sends signal to the control box where the leakage of gas is displayed, and the supply of gas towards the burner is immediately cut down. As shown here, that the control box displays the percentage of gas detected and the status of solenoid valve. Inside the control box, we have an ESP32 microcontroller that comprises an inbuilt Wi-Fi module through which we get the message of detection of gas remotely on our mobile through an Android application that we have developed using Java programming. Or you can get the same information at some other IoT platform as per your convenience. So as soon as we get the intimation of the leaked LPG gas in our kitchen, we can either have the automatic mode of our project on, through which it will automatically cut the supply down, or we can contact anyone at our home to take the required immediate action. Another benefit of this project is that when we have to leave children alone at home and we are out of station and we do not want our children to turn the gas on, we can control this remotely from the application that we have in our mobile, so that the children could not turn the gas on. Or if all of us are out of station and we do not remember whether the gas supply was turned off properly, we can control it remotely using the mobile application. Now coming to the demonstration of the project operation, you can see that as soon as we turn the control box on, the first thing that we get here represented with is the project name. Then we are represented with the status of the leaked gas, that is the output of the gas sensor, and the status of gas valve, that is the solenoid valve that it has detected by the IoT server that the solenoid valve is currently off, which can also be seen in the interface of the application that we have displayed on the screen on left side. So here, even if we turn our burner on, we can see that no gas supply is there, so it won't burn. It is because the solenoid valve is closed yet. Now, if we turn it on the application, now the solenoid valve has opened, and now when we will turn our burner on, we can see that it will light up. So here the flames are visible. Here you can see that as soon as the solenoid valve got opened, the gas supply also turned on, and the status of leaked gas is still 0%, and the status of gas valve can be seen on the control box. Following the working of the gas supply system of our project, now we will be demonstrating the working of the leakage detection part. So here, taking into consideration the safety precautions, I'll turn off the burner. So as discussed in the video earlier, here we have used an extension in the gas supply towards the burner, where we have the control of the pipe with a knob, and above it we have placed an MQ6 LPG detecting sensor. By turning the knob, we will turn the supply of the gas towards the sensor on. So here you can see that the gas sensor detects the presence of gas 26.89%. Even on the app interface, we can see the percentage of gas, and here we get the message leakage detected as soon as the gas percentage reaches 100%. And the gas valve automatically turns off as it can be displayed on the control box, and now the percentage of the gas particles can be seen as decreasing in the control box. So in this case, even if we turn on the burner, it will not get turned on as the solenoid valve has automatically closed. The percentage of gas particles can be seen here. It is reducing continuously. Turning the valve on again, here we can see that the leaked gas is again detected by the sensor and it reaches the 100% value, and the solenoid valve gets off again. The percentage of leaked gas is also being displayed on the application interface as we are displaying continuously on our screen. And since the valve is off now, the leaked gas particles are continuously decreasing as being portrayed. 20% is left. So it can be seen that how easy this project makes the task of controlling the gas supply safely and remotely. As we had turned the solenoid valve open, here we can test the burner. It's lighting up and leakage of gas is still there. Now since we have closed the knob, we can see that the leaked gas particles are decreasing. Its operation shows that it is such a reliable project that knowing that our home consists of such a safe and secure gas detection system also provides a peace of mind to the residents, even if they are at home or not at home. So here it can be seen that the gas valve is off and the leaked gas particles have also reached almost the minimum value. But our gas burner cannot be turned on since our solenoid valve is off. So this is something that everyone can rely on when it comes to the safety of their houses. So this project has simplified the task of turning the gas supply to so much extent that we just have to turn it on from our mobile using the application interface, and it will turn the entire system on. So the flow of signal is from, like here we can see that the burner would turn on. So as soon as we give the instruction from the application, it is detected by the IoT server, and from which the control box instructs the rest of the components, and this is how the entire signal flow works in this project. So now summarizing the most important aspect of this project, that is the technologies that have been deployed in this project throughout. So the control box comprises of a microcontroller, that is ESP32, that has an inbuilt Wi-Fi module which provides the internet facility to our system, with which it has been possible to make this project an application of Internet of Things. Other than Internet of Things, this project can be covered in various domains and can serve as a best example for home safety and automation projects. It can also be counted as an electronics project. Other than this, it can also be counted as a telemetry project for we are counting, or we can say that we are measuring the quantity of gas particles that are being detected by the MQ6 LPG detecting sensor. Besides, this project is also suitable as an example of the embedded systems. Plus, it also serves as a good example of the wireless communication since it does not any wires for transmission of information of the leaked gas. Further, since we have used a mobile application for the transmission of the leaked gas information, it can also work as a project of Android application development. Thus, we can see that we can serve for multiple domains with the help of a single project. In addition to kitchen safety, this project can also be implemented in the gas cylinder storage areas where multiple cylinders are placed at a single location, and in case of leakage it becomes quite difficult to detect that at which place the gas has leaked. So it works as a security and safety measure for such locations as well. So that's all about our today's project on IoT-based LPG gas leakage detection system. I hope you all liked this project. If you want to buy this project, you may contact on the number given on the screen. You may also discuss any queries regarding the same, or you may go to the link given in the description as well. Don't forget to subscribe our channel to stay tuned with many more project ideas like this. Thanks for watching and have a good day.